All right, so today we're going to dive into simulations. You know, these like computer models that let us kind of poke around at real world stuff, but virtually.
Yeah.
And we've got some really cool sources from this YouTube channel called Code Curious that really break down how these like digital experiments actually work.
Yeah, and the idea is to think of a simulation as this like digital representation of something much more complex, right? It's kind of like a simplified version, which they call an abstraction.
Okay, abstraction.
Yeah, like we're building these models in the computer to analyze things that would be, too difficult or dangerous to study directly in the real world.
So like for our listeners out there, as we get into this, it's important to remember that although simulations have like incredible power, they're not, perfect copies of reality. And our sources make it really clear that they have built-in limitations because of the choices that are made when creating them.
And a really cool thing about simulations is how they can capture this like unpredictable side of the real world.
Yeah.
They use these things called random number generators, which is basically a fancy way of saying the computer introduces chance. Like it can mimic the variability we see, so the analysis is, much more dynamic.
Okay, well, let's get right to the heart of it. Like, what exactly is a simulation, and why should our listeners care about why we make them?
Well, as the first video describes, a simulation is about using computers, right, to represent real-world stuff so we can really get in there and try to understand them better. And a model that zeroes in on the parts that are important to what we're trying to understand.
It's like we have this like scaled down digital version of reality that we can like play around with and learn from.
Right, and the goal is really, as they say in the source material, to help us understand more and test our ideas. I mean, we can run through so many scenarios in a fraction of the time it would take in the real world.
And that lets us find problems early or try different things out.
Yeah, exactly.
Now, we mentioned limitations earlier, and our sources really stress this. Like, what are some of the built-in constraints with computer simulations that we should be aware of?
Well, one of the examples they give is about simulating someone driving a car. They say the simulation might be set up assuming the driver is at least 16 and always wears a seatbelt. And in most situations, those are pretty reasonable assumptions. But the source points out that in the real world, like, a younger child could theoretically get behind the wheel, so that initial assumption about age, while practical for the simulation, introduces a simplification, like a bias.
Right, so even in setting up the ground rules of our virtual world, we're making choices that shape what can and can't happen.
Yeah, and the first video also makes a really important point about the data we feed into a simulation. Like, if the information we use to build our model is, incomplete or skewed in some way, then the results are going to reflect that. It's like if you start with bad ingredients, your recipe isn't going to turn out very well.
So where do we see these simulations being used in the real world? The first video gives some really good examples.
Oh, they're everywhere. Like, some of the most obvious ones are in games. When you see like digital dice roll or a spinner in a game, that's basically a simulation mimicking chance and randomness.
Yeah.
I mean, imagine if you had to physically roll dice for every action in a game.
Oh my gosh.
Yeah. And simulations go way beyond games. Like in chemistry, they let scientists analyze how chemicals react on a level that's almost impossible to see directly. Air traffic control relies heavily on simulations to manage, the flow of airplanes.
Wow.
And a more dramatic example is like car crash simulations, which are super important for testing safety features and stuff.
Yeah, those car crash simulations are a perfect example of how we can study something dangerous without actually, putting anyone at risk.
Right, and that actually brings us to this true or false section from the first video that really helped solidify some of the main ideas about simulations.
Ah, yes. Those were good. Okay, so let's go through those. The first statement was, a simulation will always have the same result. And they said that was
False. The dice rolling example they gave really illustrated it well, because simulations have that random element. The same simulation can, and often will, produce different outcomes when you run it multiple times. I mean, that's kind of the point, to model how unpredictable the real world is.
Okay, next we have a simulation investigates a phenomenon without real-world constraints of time, money, or safety. And that one was deemed true. So why is that so important for our listeners to understand?
Well, that's like a fundamental advantage, right? We can fast forward through years of environmental change, spend billions virtually, testing infrastructure designs, or like we were saying with car crashes, explore super dangerous situations without any consequences.
Yeah.
So we're bypassing these limitations, which opens up so many possibilities for analysis and understanding.
Then the third statement was, a simulation has results that are more accurate than an experiment. And that one they said was false, which may seem a little counterintuitive at first.
It is an important distinction to make. Simulations are estimations based on the model. And experiments, if done correctly, will give us actual real-world results. So while a well-designed simulation can be super accurate, it's still just a representation.
So the necessary simplifications we talked about mean that it can't capture every single detail.
Right.
And the last one was a simulation can model real-world events that are not practical for experiments.
Yeah.
And this one was true.
Yeah, which really brings home the safety and feasibility stuff we were talking about.
So like trying to study, the very early universe or the long-term impact of some policy, those are things we can't really experiment with directly, but we can build simulations to explore potential outcomes.
Exactly.
Now, the first video walked us through a scenario about a researcher studying a hawk population. What did that example teach us about how accurate simulations can be?
That example showed all the different factors that influence how well a simulation reflects what's really happening. Like the researcher's initial prediction based on 5 years of data wasn't exactly spot on with the actual hawk count. So the question became, which action is least likely to make the simulation more accurate?
And the answer was interesting, wasn't it?
Yeah. Removing data and simplifying things to make the simulation run faster, that would be the least effective way to improve the accuracy. In fact, it'd probably make it worse.
Yeah, you're basically getting rid of pieces of the puzzle.
Right. They were saying that gathering more data, factoring in other species, or even the weather, all those things would make the simulation more accurate because you're building a more complete picture of what's happening.
They also had a great example about an elevated train system. How did that show the real-world power of simulations?
That scenario showed how they can be used to solve problems before they happen. Like by simulating how that train system would work before they even started building it, engineers could identify safety hazards or traffic issues, and that lets them make changes when it's much cheaper and easier, right, than after the system is already built.
It's like a virtual test run, figuring out the kinks before they become real problems.
Exactly. You get to explore all the different what-ifs and see problems before they happen.
Then there was that contrasting example with the retail company wanting to know what sold best online. Why was a simulation considered the least useful option there?
Well, that really highlights when simulations are most valuable.
Okay.
And it's when we don't already have the real data.
Yeah.
Like the company already had its sales records, so a simulation would be unnecessary and probably less accurate than just looking at the numbers.
Right. If you have the real data, why try to approximate it? That definitely clarifies when a simulation is the best tool for the job. Now, the second video went deeper into comparing simulations with traditional experiments. What were some of the key differences they talked about?
Well, experiments, involve the real physical world,
Right.
and they need real materials and equipment and all that. Simulations work with those abstract digital models, all inside a computer.
What about the cost and the time it takes to get results?
Generally speaking, simulations are less expensive and way faster.
Okay.
You can simulate years of activity really quickly. Experiments, on the other hand, you're limited by how much time things take in the real world and how much it costs for materials and labor.
And as far as the results go?
Well, as we said before, experiments give you actual results.
Uh-huh.
What actually happens. Simulations give estimated results.
Okay.
It's a prediction based on the model.
And the practicality and safety stuff came up again in this comparison too.
Right. Oh, yeah, for sure. Simulations are amazing for modeling events that are impractical or dangerous. Experiments, on the other hand, well, you got to think about safety and if it's even possible to do it. Like you wouldn't want to cause an earthquake to study its effects, but you can make a really sophisticated simulation to explore potential outcomes.
Right.
Yeah.
They also mentioned that simulations often leave out certain details on purpose to make them work better. Can you give an example of that?
Sure. Like think about simulating a dice roll.
Okay.
When you roll a die in real life, stuff like the weight of the die, how hard you throw it, even gravity all affect the outcome.
Uh-huh.
But in a computer, we just use a random number generator to get a number between 1 and 6.
So we're just looking at the end result,
Yeah.
not the complex physics behind it.
Yeah, and the video said that in fields like medicine or pilot training, simulations might start by leaving out complex details like weather, in a flight simulator,
Right.
so the user can focus on the main skills.
And then later on, add more details in as needed.
Exactly.
Now, the sources gave us some more examples of when it's better to use a simulation than a straight calculation. What were those?
They talked about how insects spread on a farm or the impact of carbon emissions.
Right.
Those are really good examples for simulations because there are Tons of interacting factors, many of them unpredictable, so a simple calculation wouldn't work very well.
While something like keeping score in a game, that's just straight math.
Yeah, exactly.
Like those situations have clear rules and you have the data, so direct calculation is best.
You don't need to simulate adding points in a basketball game, you just add them.
Right, exactly. Now, the second video kind of circled back to the limits of simulations. What was the main message there for the listeners?
Well, the main thing to remember is that they're based on assumptions about the real world.
Okay.
We build a model, but that model is always going to be simplified. It's impossible to include every detail.
Yeah.
So the results depend on how good those assumptions are.
So as our listeners go about their day and encounter simulations or hear about them, what are the key things to take away from our deep dive today?
I think the big takeaways are that simulations are super powerful tools that can really help us understand complex systems, especially when experimenting in the real world just isn't feasible. They give us perspectives on safety, efficiency, and potential outcomes in so many different fields.
But we can't forget about that simplification aspect.
No, definitely not. While they're super useful, they aren't perfect reflections of reality. They have to simplify things, and that means the results are really good estimations, but not absolute truth.
Yeah, that's super important to remember. Now, to wrap up today's deep dive, here's something for all of you to think about. With AI and computing getting so much more powerful, how might our ability to make these really detailed simulations change how we understand and interact with the world in the future? It's a pretty fascinating thing to consider as these digital tools become more advanced and a bigger part of our lives.